Good morning, folks. Let's dive into structural systems here this morning. So we'll talk about kind of some general systems that are very high level and then talk more material specific systems. So you can break different structural systems into a variety of types. So form active, we're really using the form as the primary driver. Surface active, vector, which we do a lot of, and then section active, which we do an equal amount of as well. So form active really uses the extreme efficiency of the structure to carry the forces. So arches and cables are good examples of that, where they're highly efficient, but they have limited application or not full application to all the areas we need to have. Surface active are shells, plates, folded plates, whatnot. Those tend to be very popular for marquee type buildings, large spans. They're very efficient because of their shape. Vector active, so trusses, the Epcot Center structure, those really are driven by axial forces in the members, hence the name vector active. And then section active is really a lot of the members we use where they're just in pure bending or like a column. So looking at material-based systems, this table will give you different types of systems. So here we have a lintel and then a common span range in feet. So lintels, this was like a beam in a masonry wall. 20, 25 feet, they kind of tap out. Timber you can see for trusses and beams, light trusses at least, we can go about 70 feet. Heavy trusses up to 200 or so. And these aren't hard and fast rules. These are just common ranges that these types of members will span. Reinforced concrete, a typical beam, maybe up to 80 feet. Domes up to 500 feet. And then with steel, we can go to suspension frame or space frames, cables, where we really don't have a limit on their size other than just the technical realities of designing something that large. One of the key concepts I want you to take away from me is keeping it simple. We have some pretty fantastic software today that can analyze all kinds of stuff we didn't even dream about even 10, 15 years ago. But that doesn't make up for just a simple, clean layout. So as you're working on a building or a structure in the early phases, the more you can flex your muscles and get good, simple, clean layouts, the better life will be for everybody. They're easy to design, they're cheaper to build and maintain. Okay, in this slide I've given you some common physical dimensions for different types of buildings. These are just a guide. There's nothing set in stone with these, but it gives you kind of a feel for how things play out in the world. And then this table gives you some insight into different advantages or design considerations and what types of material and systems tend to work best with those. So if we're looking for a blast resistant building, we're probably not using wood, but if we want something that's easy to modify, we're definitely using wood. Okay, similarly, a similar table with different gravity system advantages or systems that work for different things the best. All right, so looking at masonry, typically most masonry, structural masonry, is made out of reinforced concrete masonry unit these days. Some of the advantages and disadvantages are listed here. You can read those. Masonry tends to be really effective from a cost point of view, durability for most types of structures, and fairly easy to use or to build. Preliminary sizing guide for masonry. So lintel, if you have a 25-foot span, maybe start around a 46 inch deep masonry lintel and maybe round that up to an even 8 inches. Preliminary column sizing. So jumping into concrete. Concrete is fantastic in foundations. Structures that need to be watertight or have water as a normal part of them, like in a water treatment plant. Depending on the part of the country, we may do more concrete than steel or vice versa, just depending on what's available. So you can kind of go through these slides and read them, maybe look online at some other options, and then in class we'll chat more about them. The two main lateral systems are shear walls out of concrete, where it's basically just a bearing wall that also carries lateral load. And then moment frame, where the beams and columns are rigidly connected to gain their lateral strength. Here's some preliminary design guide or guidance for concrete beams and then columns as well. And again, these are just starting points for design, just to give you a gut feel of how big something's going to be for a given span or number of stories in the case of the columns. All right, timber tends to be extensively used in homes, 1 and 2 stories. We see it a lot around Salt Lake in multifamily housing, 4, maybe 5 stories. There's also a huge push around the world for mass timber to have 15, 20-story buildings out of timber, and that's pretty exciting type of stuff. All right, trusses are very efficient, very common in timber. Most houses, or not most, but many houses around the U.S. will have timber truss roofs. Bearing and shear walls, this was taken just down the street from my house. Just a simple one-family dwelling going up. Here's a mass timber picture where you can see things are getting heavier. The beams are glue lams. They're actually using braces out of wood. Here you can see they're flying in a floor panel, which is quite thick, and it's landing into some prefabricated connectors there. Some preliminary design guidance for you, and these are tables as we go through this semester and other classes. You can come back to these and say, oh, now I'm taking timber class. I've got to design a solid sawn beam here, and I've got a 20-foot span, and I'm going to guess it's in the 16, maybe 18, maybe 14-inch depth range, and then start the calculations and develop the nuances of the actual problem. Brace frames are in steel. The two main lateral systems are brace frames and moment frames. You can see in these examples, these are unbonded braces. They're somewhat of a proprietary animal. These are just tubes over here. Here's a moment frame building that has very heavy side plate type connectors, and then actually this has side plate on it as well. It's kind of hard to see given the scale of the picture. Steel plate shear walls exist, though they're not particularly common. And then like the other materials, here's some preliminary design guidance. All right, so that wraps up things here. Bottom line is keep it simple. The more thought you can have and the more influence you can have early on the project, the easier it is going to be for you to design and draw, easier for people to fabricate, and that all equals lower cost. And that doesn't mean you can't have fantastically beautiful creative structures. Just give it some thought early. Make the right decisions, or right's not the right word, but make good decisions for what's going to do the best for the client and your schedule.